A Marine Corps F-35B used its onboard sensors to function for the first time as a broad-area aerial relay node in an integrated fire control weapons system designed to identify, track and destroy approaching enemy cruise missiles from distances beyond the horizon, service officials announced. A Navy desert ship at White Sands Missile Range, NM, designed to replicate maritime conditions, used ship-based radar to connect the F-35B sensors to detect enemy missiles at long ranges and fire an SM-6 interceptor to destroy the approaching threat. The emerging fire control system, called Naval Integrated Fire Control, Counter-Air, or NIFC California, was deployed last year on a Navy cruiser serving as part of the Theodore Roosevelt Carrier Strike Group in the Arabian Gulf, Navy officials told Scout Warrior. NIFC California has previously operated using an E-2D Hawkeye surveillance plane as an aerial sensor node. The use of an F-35B improves the sensor technology, reach, processing speed and air maneuverability of the system. The test also assessed the ability of the system to identify and destroy air-to-air and air-to-surface targets. This test was a great opportunity to assess the Navy's ability to take unrelated technologies and successfully close the fire control loop, as well as merge anti-surface and anti-air weapons into a single kill web that shares common sensors, links and weapons. Anand Patel, Major Program Manager for Future Combat Systems in the Program Executive Office for Integrated Warfare Systems, said in a written statement. The test was a collaborative effort across the Navy and Marine Corps, White Sands Missile Range and industry partners, leveraging a U.S. Marine Corps F-35B and the U.S. Navy's Aegis weapon system. This test represents the start of our exploration into the interoperability of the F-35B with other naval assets, said Lieutenant Colonel Richard Drusnock, VMX-1 F-35B detachment officer in charge. A multi-target ability requires some adjustments to fire control technology, sensors and dual missile firings. The SM-6 is somewhat unique in its ability to fire multiple weapons in rapid succession. An SM-6 is engineered with an active seeker, meaning it can send an electromagnetic targeting ping forward from the missile itself, decreasing reliance on a ship-based illuminator and improving the ability to fire multiple interceptor missiles simultaneously. Unlike an SM-3, which can be used for terminal phase ballistic missile defense at much farther ranges, the SM-6 can launch near-in offensive and defensive attacks against closer threats such as approaching enemy anti-ship cruise missiles. With an aerial sensor networked into the radar and fire control technology such as an E-2D Hawkeye surveillance plane, the system can track approaching enemy cruise missile attacks much farther away. This provides a unique, surface warfare closer-in defensive and offensive weapons technology to complement longer-range ship-based ballistic missile defense technologies. Once operational, this expanded interceptability will better defend surface ships operating in the proximity or range of enemy missiles by integrating an ability to destroy multiple approaching attacks at one time. NIFC California presents the ability to extend the range of your missile and extend the reach of your sensors by netting different sensors of different platforms, both sea-based and air-based, together into one fire control system, Captain Mark Vendroff, DDG-51 Program Manager, told Scout Warrior in an interview last year. NIFC California is part of an overall integrated air and missile defense high-tech upgrade now being installed and tested on existing and new DDG-51 ships called Aegis Baseline 9, Vendroff said. The system hinges upon an upgraded ship-based radar and computer system referred to as Aegis Radar designed to provide defense against long-range incoming ballistic missiles from space as well as near-in threats such as anti-ship cruise missiles, he explained. Integrated air and missile defense provides the ability to defend against ballistic missiles in space while at the same time defending against air threats to naval and joint forces close to the sea, he said. The NIFC California system successfully intercepted a missile target from beyond the horizon during testing last year aboard a Navy destroyer, the USS John Paul Jones. The NIFC California technology can, in concept, be used for both defensive and offensive operations, Navy officials have said. Having this capability could impact discussion about a Pentagon term referred to as anti-access/area denial, wherein potential adversaries could use long-range weapons to threaten the U.S. military and prevent its ships from operating in certain areas, such as closer to the coastline. Having NIFC California could enable surface ships, for example, to operate more successfully closer to the shore of potential enemy coastlines without being deterred by the threat of long-range missiles. In particular, NIFC California is the kind of technology which, in tandem with other sensors and ship-based weapons, could enable a larger carrier to defend against the much-discussed Chinese DF-21D carrier killer missile. The emerging DF-21D is reportedly able to strike targets as far as 900 nautical miles offshore. Defensive applications of NIFC California would involve detecting and knocking down an approaching enemy anti-ship missile, whereas offensive uses might include efforts to detect and strike high-value targets from farther distances than previous technologies could. The possibility for offensive use parallels with the Navy's emerging distributed lethality strategy, wherein surface ships are increasingly being outfitted with newer upgraded weapons. The new strategy hinges upon the realization that the U.S. Navy no longer enjoys the unchallenged maritime dominance it had during the post-Cold War years. During the years following the collapse of the former Soviet Union, the U.S. Navy shifted its focus from possibly waging blue water combat against a near-peer rival to focusing on things such as counter-terrorism, anti-piracy and board search and seizure, or VBSS, techniques. More recently, the Navy is again shifting its focus toward near-peer adversaries and seeking to arm its fleet of destroyers, cruisers and littoral combat ships with upgraded or new weapons designed to increase its offensive firepower. The current upgrades to the Arleigh Burke class of destroyers can be seen as a part of this broader strategic equation. The first new DDG-51 to receive baseline 9 technology, the USS John Finner DDG-113, recently went through what's called light-off combat testing in preparation for operational use and deployment. At the same time, the very first Arleigh Burke-class destroyer, the USS Arleigh Burke or DDG-51, is now being retrofitted with these technological upgrades, as well, Van Droff explained. This same capability is being backfitted onto earlier ships that were built with the core Aegis capability. This involves an extensive upgrade to combat systems with new equipment being delivered. New consoles, new computers, new cabling, new data distribution are being backfitted onto DDG-51 at the same time it is being installed and outfitted on DDG-113, Van Droff said. There are 7 flight IIA DDG-51 Arleigh Burke-class destroyers currently under construction. DDG-113, DDG-114, DDG-117 and DDG-119 are underway at a Huntington Ingalls Industries shipbuilding facility in Pascagoula, Mississippi and DDG-115, DDG-116 and DDG-118 are being built at a Bath Iron Works shipyard in Bath, Maine. Existing destroyers, the new USS John Finn and all follow-on destroyers will receive the Aegis Baseline 9 upgrade, which includes NIFC California and other enabling technologies. For example, Baseline 9 contains an upgraded computer system with common software components and processors, service officials said. In addition, some future Arleigh Burke-class destroyers such as DDG-116 and follow-on ships will receive new electronic warfare technologies and a data multiplexing system which, among other things, controls a ship's engines and air compressors, Van Droff said. The Navy's current plan is to build 11 Flight IIA destroyers and then shift toward building new, Flight 3 Arleigh Burke-class destroyers with a new, massively more powerful radar system, he added. Van Droff said the new radar, called the SBY-6, is 35 times more powerful than existing ship-based radar. Flight 3 Arleigh Burke destroyers are slated to be operational by 2023, Van Droff said.